Welcome to a new machine learning tutorial. In this video, we are going to talk about k-nearest neighbors classifier. We are going to talk about the theory of the algorithm. We are going to code it using Python scikit-learn. We are going to talk about its parameters, and we are going to do hyperparameter tuning for optimizing the model's performance. Let's start coding. Okay, so I'm going to be using Visual Studio Code in this tutorial, but you can use any code editor that you want. I will say knn classifier dot hypermb. And I'm going to go with the Jupyter notebook on this tutorial. I'm going to select my kernel in here and I will say k nearest neighbors classifier. And let's talk about this. So k nearest neighbors is a simple non-parametric algorithm used for both classification and regression tasks. But in this tutorial we are going to be focusing on the classification side. The model classifies a data point by looking at the k nearest data points from the training set and assigning it to the majority class. The algorithm works based on the idea that similar things are near each other in feature space. And it works by calculating the distance between data points in a multidimensional space. And it typically uses Euclidean distance, which we can think like, I'm going to create a new markdown cell in here. Think of two data points like x1, y1 and x2, y2. Think this like coordinates in a coordinate system. Now for the Euclidean distance we will say square root, we will say x2 minus x1 power 2, and we will say like y2 minus y1 power of 2, like this. This is going to be our formula for the Euclidean distance. And after calculating the distance to all training data, the algorithm selects the k nearest points and performs a majority vote. For example, if 3 neighbors are used and 2 are class A, while 1 is class B, new point is going to be classified as A. Okay, now we can start coding. I will say from scikit-learn datasets import make classification. Next up, I'm going to say x and y. I'm going to say make classification, number of samples, let's say 400, number of features, let's say 5, and number of informative, let's say 3, number of redundant, let's say 1, and next up what I'm going to say is number of clusters per class, 1. So we are going to have a x matrix like this, actually the capital letter, and y vector like this. So we have a binary classification problem, as we can see from here, with ones and zeros in the side. And at the y.shape side we have 400, we have the x.shape 405, so our data is ready to go. Now we are going to be starting with training a base classifier, and then I'm going to talk about the parameters that we can tune, and we are going to do hyperparameter tuning for optimizing the model performance. And we are going to see if we can increase the accuracy score. So I'm going to continue with, for the base classifier, I will say from scikit-learn neighbors import k neighbors classifier. Next up, from scikit-learn model selection import train test split for data splitting. By the way, if you don't know accuracy score or train test split or these machine learning concepts, I have a machine learning tutorials playlist where you can reach from the description of this video or from the cards of this video. I have more than 40 tutorials just like this one on machine learning. You can learn machine learning from that playlist. So next I will say from scikit-learn.metrics import accuracy score. So we are going to be using it for evaluating our model. I will say xtrain, xtest, ytrain, ytest, and I'm going to use train test split. I will pass x, y, and test size of 0.2, which means that 20% of the data is going to be in the testing set and 80% is going to be in the training set. And I'm going to initialize the k nearest neighbors with, like, I will say k neighbors classifier. I'm going to set a number neighbors value in here, like I will say 3. We are going to see how we can optimize this value. Next up, I'm going to import warnings, and I will say warnings, filter warnings, ignore, because I don't want to see any type of depreciation warnings. I don't think I'm going to get one, but I just want to make sure of that. Next I will say xtrain, ytrain, I'm going to train my model. Now we can make predictions with this classifier. Like we can say can predict, and if I pass the X test inside here, we are going to have an array like this. So I'm going to save this to something like Y predictions, and I'm going to compare them with the real Y values we have. So I will say accuracy score, Y test with Y predictions. So this is our accuracy score. By the way, it's quite high, so I don't want this high accuracy score. I'm going to change this to something like, let's say, number of informative 2. So I'm going to be rerunning all this and try it once again for seeing how it's going to perform. Yeah, okay, better. We have 0.85. By the way, since we are creating this data synthetically and we don't set random state, whenever we say run all, we are going to have new accuracy score on here. So let's keep doing this and find a not really accurate one, because I want to show you how we can optimize the model performance using hyperparameter tuning, since in the real world datasets it's not this easy to get this high accuracy scores. So it's 0.81 right now. We can continue with this one. Next up, let's talk about the parameters on this model. So we are going to be talking about 3 parameters. Firstly, the first one is K, which we can also refer as number of neighbors. This is the number of nearest neighbors for sure. Simple. And we have weights. It determines how each neighbor contributes to the classification. It can be uniform or distance. So uniform means all neighbors contribute equally, and it's defaultly this. And by distance, neighbors contribute proportionally to their distance. You can think like closer neighbors have a stronger influence. Next, I'm going to say P, and this is the power parameter for the Minkowski distance metric. And if the P value is 1, it means Manhattan distance, and if it's 2, it's Euclidean distance, which we talked about the formula in here, and it's defaultly this. It's defaultly 2. Okay, let's code it. So we are going to use grid search for selecting the best combination of hyperparameters. So I will say from scikit-learn model selection import grid search cross-validation. Next up, I'm going to define the range for the hyperparameters. Like parameter grid is going to be equal to the, let's go step by step with the same order in here, number of neighbors. It can take values like 1, 3, 5, 7, 9. We can extend this list, like you can add 12, 14, 15, 17, completely up to you. I think it's enough. Next up, I will say weights, and it's going to be uniform and distance, and I'm going to give P in here, and for the power we will say 1 and 2. Great, so now we are going to initialize the grid search. Like grid search is going to be grid search cross-validation, K neighbors classifier, and I'm going to give the parameter grid in here. I'm going to set the cross-validation as 5, and next I will say scoring accuracy. So we are going to have it in here. Now we can fit the grid search using the fit method on training data like this, and we have it ready right now. We can see the best parameters by calling best parameters, and it's 15 for the number of neighbors, 1 for the P, uniform for the weights. Okay, so now we can make predictions with our best estimator. I will say grid search best estimator.predict, and I will pass the X test in here. So we are going to have an array like this. I'm going to save them to something like Y prediction like this, and I'm going to take the accuracy score on Y tests with Y predictions, and it is 0.83. So let me check the first value. It was 0.81, and we did hyperparameter tuning for increasing it to 0.83. Great. So this is how we can do hyperparameter tuning. And if you want to export this model for using it in your apps, you can use joblib, and you can say like joblib.dump, and you can say grid search best estimator, and you can name it like, let's say knn.pickle. So we are going to have our model ready in the Explorer in here in the same destination where you run this code. And next up, what you can do is If you want to use that in another app, you can say joblib.load and you need to give the model name you set, like knn.pickle, and after that you can use its methods, like I will say predict, and I'm going to give like a two-dimensional array. We need to give two-dimensional arrays to the models, and I'm going to make this run, and we get the prediction, the class of 1. This is how we can use these models using joblib and how we can export that. Okay, so let's summarize what we did in this video. We firstly talked about the k-nearest neighbors classifier, and we talked about the logic behind that. Next, we talked about the Euclidean distance and its formula. Next up, we create our data using make classification from scikit-learn, and we used k-neighbors classifier trying to split accuracy score in here. We applied data splitting for having training and testing sets. We initialized the base model with a random value. Next up, we fitted this, which means that training the model, and we make predictions with the model we trained, and we get the accuracy score of 0.81. Next up, we talked about the parameters the model can take, and then we did hyperparameter tuning, which means that finding the best performing hyperparameters for optimizing the model performance. And again, you can extend this list, you can add numbers to it. Then we set grid search, we fitted it in here. Next, we check the best parameters after training it, and we make predictions using grid search best estimator, and we got the accuracy score of 0.83. So at the final step, I showed you how you can export this machine learning model and how you can load it back in your apps for making predictions. Thanks for watching. Let's get to the outro. Thanks for watching this tutorial on k-nearest neighbors classifier. I'm sharing new data science videos every week on my channel. You can subscribe to my channel for more videos like this. Also, I have a machine learning tutorials playlist where I have more than 20 videos just like this one. You can reach that playlist from the cards of this video or from the link in the description. Have a great day.